Welcome to our set. Today I just introduce you about set and type of set. So before we start to uh, study about set, we have studied already about what is logic. So in this time, I just said, hello everyone. What do you think about set? It means that what is set mean in our mathematics, or what is the group mean our mathematics. So this is just some of thinking about sets. Like this is the shape of geometry, is number, is animal, and a flower. So it is also a set. Group of mathematics book like operation book, the group of fruits, and the group of numbers, or a group of geometric shape. So this is the group and like a set. So from this one, what does about or what do you think about the sets? What does set mean in our mathematics or in our lesson about the set theory? So all this is the first I show you about the group of shape, geometry shape, group of number, the animal, flower, fruit, books, anything. So what is or what do you think about shape? Shape. So now this is and what is exactly shape? So shape can be form of anything that can be well defined or distinct. So please be careful about the word well defined. Well defined. It means in here well defined or distinct. What is well defined? What is distinct? Well defined it means that you can call relate to well defined. Well defined it means that you can denote it in about some condition of our group, of our collecting, or some other one we call what is set. Set is a collecting of something, or collecting of number, or collecting of our letter, collecting of our uh, animal or something. This is a set. But in this time, I introduce you about set can be form of anything that can be well defined or distinct. And what is well defined and what is this distinct? So what is well defined or distinct mean? Distinct mean example, a set of number from 1 to 9. From 1 to 9. So you can denote about a set of number from 1 to 9 like 1, 2, 3, 4, 5, 6, 7, and 8, 9. So this is a set of number from 1 to 9. So it is well defined or distinct because we have the condition of number from 1 to 9. This is our exactly set. This is the set of number from 1 to 9. And another example, a set of province in Cambodia. How about the set of province in Cambodia? How many province and town in Cambodia? So you just count about Phnom Penh, about Kandal, about Kampong Cham, Kampong Thom, Siem Reap, Pravia, and also. This is a set of province in Cambodia. And another a set of day in a week. A set of day in a week it's well defined. You can count and you can think about this set like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So this is well defined or distinct. Distinct it means that a day of a week. There are 7 days, so you count only 7 days. And well defined is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. This is our well defined. But but a set of handsome boy, a set of handsome boy, a set of handsome boy, a set of good teacher. So it is not a set. A set of handsome boy, it is not a set. Why it is not a set? Because handsome, we cannot denote about handsome. What is handsome? How can we think? Who are the handsome? What kind of handsome? So it is not well defined to uh, something about handsome. And how about a good teacher also? A set of good teacher. What is good teacher? How is good teacher? Example, you think Mr. A is a good teacher, but other think that Mr. B is a good teacher, and other think that Mr. C is a good teacher. How can be well defined about good? We cannot well define. Just only relate to item. It means relate to the handsome boy. It relate to a boy, but it is not well defined about the handsome about the handsome and the good. But other example like our something example see a set of a set of rich people example a set of rich people. So it's also not set, not a set because we cannot denote or define about the rich. What is rich? How can we denote about rich? Who is rich? Example, you said Mr. A is richer, is rich. Mr. B is rich, and other one is rich. So we cannot define about rich. This is no set also. Like our statement, what is statement and what is other not statement. It's also set and not set. And how do we represent about set or offset? But in this case, I want to remind you on this point. So set is can be from anything that can be well defined or distinct. Or sometimes other book they write set is the collect of something, but in under of condition. Under of condition. If not under of condition, it is not a set. So you can give the definition of the set. Set can be formed of anything that can be well defined or distinct, or set is a collect something uh, under the condition. This is also the definition of the set. Please remember about this one. And about how do we represent offset. So how do we represent offset? The first list method or roster method, and the second is rule method or set of builder method. So what is list method or roster method, and what is the rule method or set of builder method? So uh, there are two representation of set. in our set relation or in our set theory. The first we can call some book they call roster method or roster form. They call about set of builder form. So please remember roster like list method. List method, you know what is list? List it can call be a counter, count the name of the element. So if you have a matrix A, if you have a matrix A, example matrix A is one example natural number. So you can call 1, 2, 3, 4, and 5. This is a roster method or list method. If you write B is equal to X, such that H belong to belong to N. This is called about the set of builder method or rule method. This is roster and the builder of method. Now, what is a roster method? A set A is a set of all letters in the word Cambodia. So we let A is have C A M B O D I A. So A name of set, C A M until A is element of set. Notice that the element of set cannot be repeated. So it happened only one time. Now our element of set in set A, we have letter A have two times. Letter A have two times. So we cannot write like this. Element of set, it has only one time. It's not repeat. So you can write about C, A, M, B, O, D, and I. This is the element of set A. So this one is set A, but we cannot write repeatedly about letter A. Letter A is only get only one time. If A have more than 10 times, more than 100 times, just only write in one time. Please remember element of set cannot be repeated. So it happen only one time. It have 100 times or it have 1,000 times, you should be write only one time. This is the element of our set. So now we get A is have the element C, A, M, B, O, D, I. This is the element of A. And the cardinality of A is equal to 7. So we write N7 and A is equal to 7. And this is a set of natural number, a set of integer number, a set of whole number, a set of prime number, and you should be know what is prime number. So this is the important set in our study. And all the set above we call roster method or roster form, or something we call about list method. What is rule method or set of builder method? Example, a set of whole number between from 0 to 1,000. It means that to 100,000. So this is the whole number between from 0 to 100,000. In this case, you cannot write You cannot write from example set A is from 0 to 100,000, like you get 0, 1, 2, 3, 4, 5 until you cannot write until 100,000 because it is so long. You cannot, if difficult to write about this one, you should be led by other letter to write or to support about your writing. So I can write set A is equal to x, where x is whole number because they call a set of whole number. So x is whole number, x bigger than 0 and x smaller than 100,000. So A is the name of set. This one is such that it belong to whole number and between from 0, yeah, between from 0, this one, between from 0 to 100,000, 200,000, and a set of odd number between from 1 to 2021. So I led to A is equal to x plus 1 such that x belong to n. X belong to natural number and 1 smaller than x smaller than 109. So why I just use only x is from 109. This one 1 to 109 because your element is 2x plus 1. 2x plus 1 is 11. If x equal 1, so we got 2 plus 1 equal 3. X equal 2, it means that you got 2 multiplied by 2 plus 1 equal to 5. X equal to 3, it means that 2 3 plus 1 equal to 7. And we got x equal to 1009. So we got 1009 plus 1. So we got 2019. This is the odd number from 1 to 3. So it means that 1 smaller than 3 or 5 or 7 until to 220 and 19 smaller than 20 and 21. So this is the condition of our set, but this is 3, 5, 7 to 1000 and 2019 is the element of set A. So please, when they ask us about the element of set x or 2x plus 1, so 2x plus 1 is the element of set. X just only a condition of our element. And type of set. Type of set. How many are there type of set? There are 12 types of set. The first is empty set. The second is singleton set. The third is finite set. The fourth is infinite set. The fifth is equal set. Six is equivalent set. Seven is universal set. 8 is subset. 9 is proper subset. 10 superset. 11 proper superset. And the last one is power set. So we should be know about what is empty set, singleton set, finite set, infinite set, equal set, equivalent set, universal set, subset, or sometimes they ask about proper subset uh, and super subset, proper super subset, and power set. Proper subset or super subset, proper super subset. This is some acting now because in my writing on our lesson, I just write only I didn't include about superset or proper superset. I just only said subset, proper subset, and power set. But I just said about set, overlapping set. What is overlapping set in my book? But now we just go to know to uh, let to go to see other example about all set like empty set. What is empty set? Empty set. Empty set is a set with no element, and the symbol of empty set is like in like this one we can call blanket or something. Yeah, we can write in this symbol of the symbol, and empty set is led by e equal to none element or e equal to empty. Uh, cardinality of empty set is n e is equal to 0 because empty set is the set has no element. If has no element, it means that it has 0. Empty set example, this one is empty set. Empty set, this one is empty set, and empty set is equal to 0. And example, I have a set. Set A has empty set is the element of set A. So the cardinality of A is equal to 1. Uh, set E and set A is different. Set E is no element and set A has only one element. Only one element. What is the element of A? The element of A is empty. So empty set is the element of A. So set A have one element and set E has no element. So the cardinality of E is equal to 0 and the cardinality of A is 1. Please remember empty set and the set has empty element or element set is empty is the different. No, please remember about this point. And what is the singleton set? Singleton set is a set with one element. So singleton is a set that has only one element. Example, single set is because or we just led by S because S is singleton. Like S equal to 1 or S equal to uh, 5 or S equal to A or S equal to empty set. So this is a singleton set. So remember singleton set is a set has one number or a set with one number. Two number it is not a singleton set, just only in general set. The cardinality singleton set is n s v led by ns is equal to 1. So this is the cardinality of singleton set. And what is finite set? You should be know about the word finite. Finite we can denote or we can count it. This is the finite. So finite set is the set we can denote about the element or limit element. Finite set is set with limited element. So we can count about the element in our set. We can call it is finite set. Finite set led by example set A is equal to have element 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 we can count. It is 5 element in our set. So this is finite set. The cardinality in finite set is NA equal to 5. But we can denote about the cardinality of A. So A is a finite set. What is infinite? Infinite, it means that we can count or we cannot denote or unlimited element. This is a finite set. So infinite set is a set with unlimited element. Unlimited element, it means that we cannot count about the element, but we can read. We can read the element, but we cannot count. Example about infinite set led by example natural number. The natural number is so many of natural number or of positive integer number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until to blah blah. So this is unlimited element. We cannot count how many elements in natural number, but we can read the natural number. Natural, it means that read, it means that we can count from one by one. 1, 2, 3, 4, 5. This is reading. But we cannot count how many elements in natural number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until blah blah. So this is we cannot count all unlimited element. The cardinality of infinite set in is led by n is equal to infinity. Infinity, it means that unlimited. We cannot count this one. Have more, but we don't know. No, but we don't know. And the next equal set, fifth equal set. What is equal set? Equal set are set with the same element. So please remember, equal set are set with the same element. The same element. Different set, but different type of set, but have the same element. Example, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A set A have element 1, 2, 3, 4, 5, and set B has element X. Such X is belong to N, and X bigger or equal to 1 and smaller or equal to 5. So B, set B is X. X belong to N and X between 1 to 5. It means that we have if N equal 1, 2, 3, and 4, and 5. So B is have element 1, 2, 3, 4, and 5. So now we check about set A and set B. Set A we have about the element of 1, 2, 3, 4, 5. And set B have the element 1, 2, 3, 4, 5. So A and B is the same element because 1, 2, 3, 4, 5 is belong to A, and 1, 2, 3, 4, 5 is belong to B. So A and B is equal set in this one. So please remember, equal set is a set with the same element. The same element. Same element, it means that the name and the number of the element is the same. So this is equal set. And this one about equivalent set. Yeah, equivalent set. Equivalent set. Equivalent set. What is equivalent set? Equivalent set have different elements but have the same number of element. It means that the set is different element, but the cardinality is equal. So this is equivalent set. Example, I have set A 1, 2, 3, 4, 5 and B 2x. X is belong to n and x between from 1 to 5. So B is have element to x and x is belong between 1 to 5. So if x equal 1 is 2, x equal to 4, 6, 5 and 8 and 10. So the set A if have 5 elements and the set B have 5 elements, but the element of A and B is different, and the cardinality of A and the cardinality of B is equal to 5. So we can say like this: set A and set B are equivalent set. Equivalent set. This is the meaning of equivalent set. And the next about universal set. And what is the universal set? Universal set is the set containing all elements and of which all other sets are subset. Example, I have U is the universal set. Why is U is the universal set? Because if I have three of the set U, A, and B, U, A, and B, but when we look to about the uh, when we look to about the set A, about set A, and about the set B, we see that the all element in set A is belong to U set or set U, and the element of B is belong to set of belong to U set. So if A, the element of A is belong to U and the element of B is belong to U, we can say like this: U is universal set. So U is a universal set. Universal set. But if example, when I said I have set C, set C have 1, 2, and 12. So C, the element of C, it is not the element of U because 12 it is not belong to U. So C it is not belong to U. It means that U it is not universal set. U it is not universal set because 12 it is the element of U. 12 it is belong, it is not belong to U. So U it is not a universal set, you know. And D, example, I don't have C, but I have D, or I don't have A or B. I have U 1, 2, 3, 4, 5, 6, 7, 8, 9, but I have D 1, 2, and E. I have 5, 9, 7. This on the example. So look to the element of D and the element of E. The element of D is belong to U. The element of E is belong to U. So U is also universal set. This is the meaning of universal set. So universal set, the set containing all elements and which all other set are subset. So it means that A can be subset of U, A can be subset of U, and B also can be subset of U. So we can write A is subset of U, B subset of U, or A in U, B in U, or A is belong to U, B is belong to to U because all element in A and B is belong to U. This is the meaning of our universal set. And about a letter, universal set about letter A, B, C, D, E, F, G, H, I. So A, B, D, H, I, and B, C, E, F, G. So A, the element of A is belong to U, and B is belong to U. So U is universal set also. And subset. What is subset? Set A is a subset of B if and only if every element in A is also an element in B. It means that the element of A is an element in B. So this is the subset if A is subset of B. So we can write about A is subset of B or A in B. This is the meaning of subset. Example, list of possible subset of A. If I have A is equal to the element S, E, and T, we have only S, E, and T. So A can be subset itself. It means that A can be subset itself. A can be subset of A. So we got about three elements is E, S, E, T, and two elements of subset SE, ST, and E, ET. So this is also subset of S, E, and T, and one element S, E, and T. And don't forget, the empty set is also every subset of other set and empty set. So the subset of set A is equal to SET, SE, ST, ET, SET, and empty set. So all this one is the subset of A. Subset of A. If we have this set A, so the subset of A. Subset of A are the first empty set, one set S, E, T, two set is SE, ST, ET, and the last one is itself. Itself, it means that three elements S, E, and T. This is a subset of set A. Subset of A have empty set, singleton set. Singleton set has three, two set has three, and three set has one. It is itself set. So this is single. This is the meaning of subset. And the next point, and how many subset does A have? It means that how many subset of A. So if A have S, E, and T, the formula for calculation is 2 power n, where n is a number of elements. So how many elements of A? A have three elements S, E, and T. So it's three elements. So the subset of A have 2 power have n element, and the subset of A is 2 power 3 is equal to 8 subset. So A set A have 8 subset of A. Like I count the first, like empty set, singleton set, two set, and itself. Now itself, it means that set A, S, E, and T. So this is 8 subset of set A. So when we want to find about how many subset of other set, we should be use about the formula 2 power n, which n or where n is the number of element. If our set have 5 elements, so it's 2 power 5 uh, is equal to 32. Example, we have set A. Set A have element 1, 2, 3, 4, and 5. And the subset of A is denoted by 5 to power 5 is equal to 32. So when we count, the first is empty set, and the next is singleton set 1, 2, 3, 4, 5, and the next is set 2 element. So 1, 2, 1, 3, 1, 4, 1, 5, and 1 is, that's all. 1, 2, and 2, 1 is the same, so we cannot write. So if we count all number 1, we just count to number 2, 2, 3, 2, 4, 2, 5, and to all we count 3, 4, 3, 5, and then we just go to 4 and 5. So 2 element of set is all. So we go to third element 1, 2, 3, or 1, 2, 4, or 1, 2, 5, anything until to 1, 2, 3, 4, 5. This is the subset of set A. They have element 1, 2, 3, 4, and 5. So you count until you have 32 subset. This is the kind of our subset. And proper subset. Proper subset, it means that the element of proper subset, it is not equal to the set, the initial set. Example, set A is a proper subset of B if there is at least one element in B not contained in A. It means that A is a subset of B. Example, if I have B is equal to 1, 2, 3, 4, and A is equal to 1, 2, 3, or 1, 2, 4. So A is a proper subset of B. But if A equal to 3, 4, so A can be subset, only subset. Because subset, the element, the cardinality of A and cardinality of B is equal, can be equal. Or we can say it is equal set. Equal set, we can be set a subset each other. A is subset to B or B is subset to A. But when I write A have only 1, 2, 3, the element 1, 2, 3, and B is 1, 2, 3, and 4. So A is a proper subset of B because the element of A is belong to B, but B, the element of B, it is not belong to A because 4 it is not belong to A. But 1, 2, 3, 1, 2, 3 is belong to B. So A is the proper subset of B. This is the meaning of proper subset. Proper subset, it means that the proper subset, the cardinality of proper subset, it is not equal to the initial set, like my expand on our slide. Example, I have set A have element A, M, A, T, A, S. So B have only M, A, T, and H. So I think that B is a proper subset of A. Proper subset of A we led by this sign. But subset we led by this sign is B subset A. Sometimes we write A subset B. A subset B or B subset A is can be vice versa. But B proper subset of A, but A we can call is a superset. Is a proper superset. The next point we have about the superset. But this point is a proper subset. B is a proper subset of A, or we can say A is a proper superset. This one, because uh, because the element of B is belong to A, but the element of A it is not belong to B because S it is not belong to B. But the element of B is belong to A. If the element of B belong to A, it means that A is a proper superset, or we can call B is a proper subset of A. And C is also a proper subset of A. And D have only two elements A and T. A and T is belong to A. So we can write D is the subset or proper subset of A. Or one more thing we can say about A and T. A and T is belong to B. So we can call D is a proper subset of B. This is the meaning of our proper subset. And the next, list all the proper subset of A. So the proper subset of A is element. In T is singleton set. It's two set, but not three set element because three set element it is not a proper subset. It is only subset. Proper subset it is not itself itself. It is not itself subset. Proper subset is only the set that have the cardinality is not equal to the initial set. Example, the cardinality of the initial set equal 3. So the proper superset is at least only 2. Only 2. The cardinality, the bigger cardinality is equal to 2. It is not equal to 3. Because proper subset, at least B have A at least one set, it is not in B. So example, set SE, ST, and ET. But when we write about SET, it means that it is itself subset. It is not a proper set. Proper set, it is not. It doesn't have itself. And how many proper set does A have? So A is have element S, E, and T. The formula for calculation is 2 power n minus 1. It's different from subset. Subset is 2 power n and proper subset is minus 1 because it is minus itself. So n equal 3 and the proper subset of A is 2 power 3 minus 1 is equal to 8. And what is the superset? Superset is a set containing all the elements of another set. A is a superset of B if every element in B is also in A. I can write A superset of B. A superset of B or B subset of A. B subset of A or A superset of B is the same meaning. What is a proper superset? A is a proper superset of B in A. A is superset of B and A beside B. So we got A is a proper superset. This is the sign of subset, superset, and this the sign of proper superset, and this the sign of subset, and this the sign of proper subset. So it is different. We can say A is a proper superset, or B is a proper subset of A. A is a proper superset of B, or we can say B is a proper subset of A. This is it meaning the same meaning. Example, I have A 1, 2, 3, 4, and 5, and B have only 1, 2, 3. So if B a proper subset of A, so we have A is a proper superset of B. This is the same meaning. And I write B is a proper subset of A. So A is a proper superset of B. This is the same meaning. And what is the power set? Power set. The set or subset of a set. The set or subset of set, like we have A, SET. So we got about empty set, singleton set, two element set, and three element set. So this is a power set. If I have A is equal to element S, E, and T, then what is PA? PA it means that power set of A. What is the power set of A? Power set of A is equal to empty set, set S, set E, set T, set SE, set ST, set ET, and set SET. This is a power set of A. So power set of A is a subset of a set. Example, when we have set A is equal to 1 and 2. 1 and 2. So the power set of A, PA, is equal to empty set 1, 2, and 1, 2. This is the power set of set A. So the power set of set A, the set or subset of a set. So all subset, this is a subset of A. All the set of subset of a set is a power set. But I have 1, 2, 3. So this is not the power set of A, because 1, 2, 3 it is not a like subset of A. Example, if I have A equal to 1, 2, 3, and I say PA is equal to this one 1, 2, 1, 3, 3, 2, 2 and 3, this one. but I didn't write about 1, 2, 3. So it has only 7, like only 7. 1, 2, 3, 4, 5, 6, 7. But we don't have about 1, 2, 3. So 1, 2, 3 is also subset of A. But in PA, it is not have itself subset. But it is not itself subset. So PA, it is not a power set of A. Power set of A, it means that all subset of A. All subset of A in one set is a power set, but it is not have about its subset itself subset. So PA, it is not a power set of A. Please remember this one. The definition is mean that the set all subset of a set, all subset of set, it is power set, but not all subset of a set, it is not a power set. This is the case of the meaning of power set. And how many elements does the power set of A have? And power set of A is equal to 2 power 3. 2 power 3 equal to 8. Equal to 8. So this is about uh, the element of power set of A. So the power set of A is equal to the subset of A. Subset of A have 4. The power set A is only 4. The subset of B of A equal to 10 or equal to 15. Equal to 15. It means that the power set of A is equal to 16 also. This is power set. So please remember about all these type of set: empty set, uh, finite set, infinite set, equal set, equivalent set, universal set, subset, proper subset, superset, and proper superset. And the last one is power set. What is the meaning of each type of our set? And now this is thank you for your watching this video, and the next video I will produce for about the operation in our set. What are the operation in our set, and how to we use about the diagram when to solve about our exercise for our letting something. So thank you very much and see you next video.